Good morning, good afternoon, good evening, ladies and gentlemen. Welcome to the EnOcean Alliance webinar. Thank you all for taking your valuable time to join us. This webinar will be recorded and we will send a link to everybody who is attending. If you have any questions during the webinar, please feel free to type them in, or please contact us afterwards and we'll be happy to answer your questions there. I'm very happy today to have our keynote speaker, guest speaker, Jeff Burns. Jeff is CEO from Magnum First. Hello, Jeff, one of our key member companies in North America. And Jeff is going to show us some of the use cases, some of the real-life case studies he's installed, and some of the key products involved. And before that, I'm just going to give a very short overview of the market opportunity and the EnOcean Alliance. So first of all, the general opportunity. For those of you who don't know us, EnOcean is all about energy harvesting wireless technology and an international open standard. And energy harvesting, or the name ambient is becoming more popular, ambient IoT, is a huge opportunity. If you look at what the industry researchers are saying or writing, I mean, just one from a few months ago, ABI research, it's a trillion sensor opportunity with hundreds of billions of opportunities in the next 10 years. And of course, one of the reasons for that is, yes, the IoT market is exploding, but how do you power these IoT nodes? Now, some of them will be powered by cable, some of them will be powered by batteries or rechargeable batteries, but a lot of these cannot be powered by cables or batteries. So energy harvesting or ambient IoT is the solution here. And just to let you know how important that is, this is a statistic I dug out earlier today. 78 million batteries are discarded per day in the EU alone. Now, if I do my maths correctly, that's about 30 billion batteries discarded every year. And it's not just about the lithium and chemicals and all this toxic waste. If you think about a lot of these batteries will be getting changed, how much time, effort, and cost does that take? So the EnOcean Alliance is all about batteryless wireless technology and bringing all these advantages to enable the IoT opportunities. We're getting a lot of support from legislation, standards and codes in the building industry. For example, you have the EPBD 2024 launched just a few weeks ago in Europe, basically saying all buildings have to be almost zero energy, zero net energy in the next 20 to 25 years, with the largest buildings actually starting this year. And as buildings are responsible for about 36% of our CO2 output, this means virtually all existing buildings will have to be retrofitted over the next 20 to 25 years. Germany has introduced the GEG 2024, adopting this. There are other laws and directives around the world. New York City Law 97, for example, Title 24, very well known in California. Also, the National Electricians Code or Electrical Code in North America, the 2023 edition, actually says battery-only powered sensors and switches are no longer code compliant. So this is another huge opportunity for energy harvesting. And also, just to let you know how this whole energy harvesting or ambient IoT is getting a huge tailwind, it's actually now in the new 5G and 6G telecom standards that are going to be released. I think version 19 of the 5G standard is planned to be released this year. That has ambient IoT as part of it. So all of this is a huge tailwind for us. And of course, everybody, countries, corporations, organizations are committed to going carbon neutral or reducing carbon. And this is all for our community. And just very, very quickly, but Jeff will go into some of this and the benefits. Obviously, if you're putting this into buildings, the advantages and the requirements are you want no batteries, no wires. You save on installation, you're flexible, you're sustainable. You want an open, interoperable standard. You don't want to be locked into one vendor. That can be expensive and frustrating. And you want true multi-vendor interoperability. Also easy to install or commission, low or no maintenance over decades. And the EnOcean standard, and what Jeff is going to show you, achieves all of these requirements. And the benefits for the user, and Jeff will show us some real life cases here, is you can save on construction times and costs. You're not pulling cables, you're not opening walls, you're not making a noise or mess. You can save on health and wellness, especially by monitoring and controlling air quality. Actually, studies show up to 15% employee productivity and motivation increase. If you're using it to measure occupancy and how many desk spaces, conference rooms, etc., being used, you can use that data to save up to 40% space in your building. And of course, as we'd addressed, energy and CO2 saving, very easy to save 30% in a typical commercial environment, and sustainable for decades. So that was my very short introduction. As I say, we're the EnOcean Alliance. We've been doing this since 2008. We've created the international standard. It's been installed in about 2 million buildings. There's about 5,000 products, and we're open to anybody to join us. So thank you for listening for me for a few minutes. I pass over now to our keynote speaker today, Jeff from Magnum. Thank you.
Thanks, Graham. I appreciate that. What they've kind of asked me to talk about today is optimizing comfort and energy savings through EnOcean-based Advanced HVAC, lighting control, energy monitoring, and IAQ Solutions. The next, if you would there. Real quick, the ecosystem of EnOcean, and there's other RF protocols out there that perhaps do lighting or perhaps do HVAC or perhaps do energy monitoring. With EnOcean, we have a full, complete ecosystem. We have our lighting controls. We can do HVAC controls. We have energy saving devices. We can monitor energy. We can look at indoor air quality. We can produce dashboards. And we can do control of all the sensors. It's two-way. We can control scheduling via occupancy or demand. The first protocol of the four between lighting, HVAC, energy monitoring, and IAQ is our lighting control devices and our plug load control devices. All of the EnOcean products are wireless, batteryless. There are door sensors. There are outlets that can be controlled via EnOcean. Switches that can go on and off, use very little energy, occupancy sensors, in-fixture lighting for Dolly, Opus, 0 to 10, just about every protocol that's out there. We also have occupancy sensors that have PIR sensors in them, lumen sensors in them, built right into them. So by putting a sensor in a room that's connected to switches and relays, we can do automatic daylight harvesting as well as occupancy control out of the same sensor. No need for wiring, no need for batteries, no maintenance. Pop it up on the roof with a couple of screws up on the ceiling and you're good to go. The next category, which is our HVAC control devices. In the thermostat world, we have 24-volt replacement thermostats. We do a lot of building BMS systems in buildings that have existing thermostats. We can go into the building, replace the thermostat with a 24-volt EnOcean enabled thermostat, bring that data back into a box that converts EnOcean over to BACnet, which we'll go through in a little bit, and build a BMS in a building that doesn't have one. Real simple, just by replacing the thermostats. We also have wireless batteryless thermostats that are out there that will communicate to radiator valves, or will communicate to boards that will control RTUs, PTACs, split units. These type of thermostats, you basically stick them on the wall. There's no batteries, no wires. They'll communicate back to those boards or back to that actuator and control the thermostat. So in many buildings that have radiator control, just by installing a valve on top of it, putting the thermostat on the wall, we now can build a BMS system within a building. Another thing that we find is there's a lot of hotels and stuff that have sliding glass doors, especially in the higher climates. The people come in, open up the sliding door for fresh air, leave the air conditioner on, and Mother Nature's kind of fighting the electric company. And we have relays that we can put one of those wireless window and door sensors and connect it directly to that sensor and actually turn off the HVAC or turn off the air conditioning unit when that sliding door is opened. As soon as the sliding door is closed, the HVAC unit goes back on. The next. Energy monitoring devices. You know, the big thing about saving energy first is realizing what kind of energy you're using. There are CTs out there that have revenue grade energy monitoring in them. And there's also devices out there that actually just clip on to wiring. They're basically wireless CTs. All that data will come back to the infrastructure we'll go through in a minute. We do a lot of these with power companies. We just did a thing with National Grid that there was a company out there that was getting some very high spikes in energy. They came in, and what they found out was that somebody was coming in and turning on 4 RTUs, 7 CNC machines, and some huge compressors all on at the same time. So they're getting a peak energy, and their energy was 6 hours. So the highest energy that was used in 6 hours is what they were charged for those 6 hours. So by using those clamp-on CTs, we were able to go in, find what machinery was going on, and be able to reduce that. So again, there's all sorts of different sensors out there that will communicate the EnOcean protocol, so we can get real-time energy management within a building or a facility. Next, the last one of the 4 different series of things that we use EnOcean for is our IAQ monitoring. Indoor air quality, since COVID, has become a very important part of a building wealth and its health. There are sensors out there like this one that are EnOcean wireless. This has temperature, humidity, CO2, ppm1, ppm2.5, ppm10, and TVOC. And again, that will communicate back into our ecosystem all of that data on that sensor. They also can be used for demand ventilation. And we'll kind of go into that a little bit in a second with a project that we did at Yahoo. So the next product line that kind of comes in that puts this whole thing together is your infrastructure devices. We have an EnOcean signal out there, and you know, we need to do something with it. What are we going to do with that signal? What are we going to do with that thermostat that has a set point and a temperature, and we need to change that set point? There's a couple different devices that are out there that we can use. The first one that we do a lot of is EnOcean to BACnet over IP. So all of your devices that are sitting out there, whether it's a thermostat, whether it's a AQ sensor for lighting, and we're using that same AQ sensor for our HVAC, whether it's metering or whether it has IAQ sensors, can all be brought into the same gateway, and those points can be sent out BACnet over IP. So what does that mean? That means that we can integrate with existing BMS systems that are out there. If it's a Siemens, a Trane, a Daikin, we can actually give them those BACnet points. They can take that BACnet points, bring them into their BMS system, do their dashboards, do their control. The other thing that we can do is we can take those EnOcean and deliver them through MQTT to a server such as an AWS or an Azure server. There are quite a few companies out there that have different software that will sit up on a server. We have one too from Fin that we can put up on a server, so we can grab all your data, put it up to a server, deliver all your graphics, all your GUI to either your cell phone or to your computer of everything that's happening in your building. We also have what's called our Smart Edge server that we can use, that again, we can take up to 5,000 points. There's quite a few companies out here that have these, and we can deliver all that graphics support and control to you. Dashboard visualizations, I'm sure everybody has seen these, but these are just some of the dashboards that we produce. You can kind of go through these fairly fast. That one is our IAQ. It shows the CO2, temperature, humidity, graphs it on the bottom. Our next one is an energy monitoring, and it also shows building efficiency, energy conserved, you know, just about anything you can dream of, energy integrity, how the building's doing compared to last year, how it's doing compared to last month. We have customers that have, you know, we're working with one now that has over 1,000 buildings. They can come in, take all those buildings, compare one building to the next of how they're performing. And we can give a graph to it, basically an index of how each building is performing. The facility managers of each building are working to get their index down as low as they possibly can. And the next. Again, pretty much the same type of energy dashboard. Today's total energy, energy this month, energy this year, and it can be all graphed and compared. A couple of different case studies of what we have done. This is a university that is in Niagara Falls, New York. And the issue that they had is they have it's actually a 6-story building. It's 6 stories of campus. And what they did is they had, when they put the system in, is they had the first floor had a thermostat in it, and that thermostat controlled all of the electric heat on every floor above it. So room 101 controlled 201, 301, 401, 501, etc. Well, the big issue that we know is heat rises. So if the person that was in room 101 was a person that liked their heat warmer, it would heat all the rooms up above it. We were there on a 40-degree day, and about 60% of the windows in this building were wide open with the students trying to cool down their rooms. The solution that we did here is what we did is we came in with a wireless thermostat, no batteries, no wires, basically with 2 screws, put it into the wall. We put a wireless relay on each one of the electric baseboard heating units. And we put an ox sensor also in each one of these rooms. We brought all those points back into a BMS system through our BACnet, through our EnOcean to BACnet box. And they were able to give individual control to each one of the students of their own individual rooms. I mean, obviously, some people are more comfortable at 66 in the winter, some people are at 72. And again, it gave the students the ability to do that, but 2, it saved a bunch of energy. There was a 40% reduction in electric cost. The ROI on this project came in less than 1 year for this project. Now, what they can do on this too is these students all go home at Christmas time, they all go home at Easter time, is they can get on their BMS system and turn all these rooms and set them all back to say 55 or 60 degrees. The day before all the students come back, they can turn them all back up. They can also tell if rooms aren't being used by the occupancy sensor, so they rate of when people are coming, when people are leaving the room. The next case study. The next case study we're doing is one that we're working on now. It's Hunt Realty. And what their issue that they have is they have offices throughout the whole Buffalo area. And they have manual thermostats in them. And the brokers that are using these buildings are coming in and out all the time. And a lot of times they'll come in, say at 11 o'clock to pick up some paperwork and sit at a desk for a little bit. And they'll turn the temperature up to 80 degrees because it's going to get warmer faster if you turn it up to 80 versus 74, is kind of what people think. Once they've done their work, they leave the building, leave it up at 80 degrees, and it stays there until the next morning when somebody comes in. They're super hot, so they turn it down to 66, then the air conditioning turns on. And they really didn't have any control of any of these buildings whatsoever at all. It was just, let's go and see what we can do. So what we did is we took out their existing thermostats and we replaced them with a 24-volt thermostat. And we brought those thermostats back into the box that converts the EnOcean signal over to BACnet over IP. We actually went in with a box that converts MQTT that sends it up to Azure server. So these locations are spread out all over, but with the EnOcean to MQT box, they were able to grab all those signals, put them up in one of the cloud services. We have a software program that can grab all those MQTT signals and all the data that's happening in these buildings. And now they have a dashboard of each one of the buildings. They're able to control the thermostats. They're able to see when they went on. They're able to see if there are people within the building itself. And what they've done is if a broker comes in now and changes it to 72 degrees is where they limited it on the high end, 60 and on the low end, it'll reset after 45 minutes if it doesn't see occupancy in the building to its offset. The local electric company rebated this about 60% of the project, and we feel there's going to be about a 2.5 year ROI on this particular project. Our next case study is 888 Delaware. It's a mansion that was put in, oh boy, I think it was 1920 or 1910. It's a historical building. They came in and they're updating everything in it, taking it from a residence to a hotel and apartments. And what they're doing in here is there's no air conditioning in this building whatsoever at all. It was just a lot of radiator heat. So what they did is they installed a whole bunch of split units in a lot of the hotel rooms, a lot of the apartments, but they wanted to keep the boiler and the radiators for efficiency of a lot of the other building. What they didn't want was two different systems, one controlling the radiators, one controlling the split units. They didn't want remote controls on the split units. They wanted one area to do it. So what we did is we came in, we installed wireless radiator valves on all the existing radiators. We installed control boards in all of the split units, and we installed one thermostat in each one of the rooms, a batteryless wireless thermostat. And now that same thermostat is controlling both the radiators as well as the split units. So we're using EnOcean over BACnet, the same thing, up to a box with software in it. We're bringing all those points in for dashboard and control, so now they can look at the room, see what the temperatures are, change the set points. They can do this on their cell phone, or they can do it via a local computer. The last case study we have is Yahoo, and it's a data center here in the US. The big challenge with data centers is trying to figure out what we're going to do with the air inside of them. The hardest thing for them to do is to keep all the servers inside these data centers cool. It's a very important part of keeping the servers operating correctly, is to keep the temperature where it needs to be. So in doing that, what a lot of the data centers do is they'll recycle the air. It's already been treated. The temperature is going to be cooler than the outside air. So they just keep recycling this air over and over again for energy savings. The problem with that is if you keep recycling air and all of a sudden you have 50 visitors come into your building and they're in an office or something and all your air is recirculating, is you're going to build up high CO2 within that facility or within that area where those people are. So what we did here at Yahoo is we installed wireless IAQ indoor air sensors throughout the building. The same thing is that an EnOcean signal comes back to our box that converts the EnOcean to BACnet. We have a small server sitting in there. And now if at any time that any of the CO2 levels get too high within that Yahoo building, they're able to go in and bring in outside air and take care of those higher CO2 levels. Staff was getting tired. They felt that they weren't concentrating. They knew that the CO2 levels were high. And, sure enough, they were in some of those office areas where people were at. So that was kind of an interesting program. And then our last slide, to kind of sum everything up, leverage demand side energy savings to attract new and retain current customers. That's kind of what we're all trying to do, I think, out there is get new customers and retain the one that we have. With the EnOcean protocol, you really have one comprehensive platform that can do lighting, HVAC, IAQ, plug load, and metering. Again, as I said earlier, there's a lot of other platforms out there. Most of them are designed either for lighting or for HVAC or for energy monitoring. With EnOcean, we can do it all. Again, one smart building automation platform delivers multiple saving applications at the fraction of the cost of an enterprise solution. All of our paybacks and ROIs are incredible. I mean, they always make sense when we're talking to building owners. It's a very flexible, scalable system. You can start with lighting, you can go into HVAC, you can add things as you go along. And MFI seamless, implementation. So with that, that's pretty much my whole presentation. Not sure if there's any questions or.
Yeah, well, thank you very, very much indeed, Jeff. That was an excellent presentation. And I'm very happy to see you showing practical examples of the key energy wasters in our buildings. The key energy wasters in our buildings are having HVAC on in areas that are not occupied. And I think you gave us one good example of that. The other energy wastage is having a window open and HVAC running. That's one of the biggest energy losses in buildings we see. So it's good to see these practical solutions that solve both of these problems. And also the indoor air quality. I don't think this is well known enough to everybody. Once the CO2 level goes up, the concentration goes down very quickly. Once you get 1,200 ppm, the concentration goes down, the productivity goes down, and also the absenteeism goes up. So this is very, very, very important that people are healthy and productive. So thank you very, very much indeed for showing this. We do have a lot of questions, but I just want to pick up on one that's here. They're asking that Matter is the new hype, the incoming thing. Everybody's talking about Matter. How does EnOcean relate to Matter, and how can EnOcean work with Matter or via thread radio? If you want, I can say a few words on that, Jeff.
Yeah, go ahead.
And then you can give us some practical advice. So Matter is an IP-based protocol, and Matter is actually independent of which connectivity layer underneath it is. Yes, a lot of people use thread with this, but you can also use Zigbee, you can use Bluetooth, you can use EnOcean, you could use BACnet, you can use anything and then hook it into IP. This is the great thing about Matter, and I'm a big fan of Matter. Matter will bring all of these protocols together at an IP level to increase your interoperability. The energy harvesting EnOcean parts can integrate into Matter networks. There needs to be some sort of gateway or device or proxy that's powered that can do the translation here, but in most applications that's possible. So EnOcean to Matter is possible. EnOcean energy harvesting devices obviously cannot speak Matter and meet the Matter spec, but this can happen through a proxy or a gateway. Don't know if you have anything to add there, Jeff?
No, that's well put.
Okay, great. And we do have a few more questions, but what we'll do, we'll answer these questions in writing, and if anyone wants to contact us and discuss any more, we're very, very happy to do this. So I'd like to say a very big thank you to Jeff for giving us this excellent presentation today. And if any of you would like to have more information or join our alliance, we're open to anybody. We'd love to have you on board. So thank you all very, very much indeed. And I wish you all a great day, great evening. Thank you very much. Goodbye. Bye-bye, Jeff.
Thank you, Graham.